and welcome back to Cosmic Ray. Today we're going to be talking about exoplanets. What are they? How do we discover them? And what are the different types of exoplanets? If you have those questions or more, this video should answer some of them. And if you want to see more videos regarding exoplanets, head over to my Instagram and you can just respond to my question boxes on my stories, and hopefully I'll be able to make another video. Now for today, I'm going to be describing what an exoplanet is and categorizing different types of exoplanets. I'll briefly mention how we actually discover most of the exoplanets, and I'll also list some really cool exoplanets that are actually like real life, not just science fiction. I'll start off with what an exoplanet is. An exoplanet is a planet outside our solar system, hence the prefix exo, or outside of. An exoplanet can be categorized into 4 different types. So there's terrestrial exoplanets, super-Earths, Neptunian, and gas giants, and that's in order of rough size. So terrestrial planets are small rocky planets. Like Mercury, Venus, Earth, and Mars are all terrestrial. So terrestrial exoplanets are just planets outside of our solar system that are in some ways alike the planets closest to our sun. You've got planets like Venus that are lava-filled and unforgiving and hot, and you definitely don't want to go there. And you've got colder rocky bodies like Mars, or bodies of water like Earth that have potential to have life because they're in what's called the habitable zone. We found a couple hundred terrestrial planets. They're not that common, they're quite rare actually. It's hard to find such small planets with that rocky composition as compared to super-Earths, which are mostly terrestrial. There's some gaseous elements, but they tend to be terrestrial at that size, tend to be rocky at that size. They're bigger than Earth, but they aren't necessarily anything like Earth. So super-Earths don't necessarily mean planets that we'll go to in the next couple hundred years to live on. It literally just means that they're rocky but bigger than Earth, as opposed to terrestrial planets which cap off at about twice the radius of Earth in terms of size. In terms of super-Earths, we found over 1,500 of those. You've also got gas giants, which are planets that are around the size of Jupiter, that are gaseous, mostly made up of hydrogen and helium, and then other elements including sulfur and carbon and whatever else you can imagine. Some planets are called hot Jupiters. So they are Jupiter size, they're gas giants, and they orbit their star so close that they're really superheated. You've also got Neptunian planets. Now Neptunian planets are really the same as gas giants, but they're just smaller, so around the size of Neptune. It's basically just planets alike in terms of composition and size to Neptune and Uranus. And they are very common. We found almost 2,000 of them. In terms of how we discover exoplanets, we've used telescopes. We've used telescopes on Earth and in space, and 2 of the key telescopes for discovering exoplanets are Kepler and the James Webb Space Telescope. Now Kepler is the telescope that has found probably the most exoplanets, especially Earth-sized exoplanets. And if you're a bit of an astronomy nerd and you've researched into Earth-like planets before, you might see a lot of them have Kepler in the name, and that's because the star that was discovered was named Kepler with a number after it, and then the planet that orbits it is named, for example, Kepler this number B, because it's a planet around that star. But then you've got the James Webb Space Telescope, and its job is basically the same as Kepler's, but it's got a lot more that it does as well. It's also taken some of the best resolution images of space and some of the best deep field images. Now, like I said, the naming of exoplanets, have you ever read an exoplanet's name and be like, bro, why not just name it Tatooine or, Dagobah or something interesting? Well, it's because astronomers don't have an imagination. No, I'm kidding. Astronomers, of course, they have an imagination. The thing is there are so many planets that coming up with an interesting name for every single one. Why would you want to come up with 5,000 interesting names when you can use an alphanumeric system? Because we're nerds and we like alphanumerics. So the typical way of naming this, a planet, is its star name, then with a letter after it, denoting its order in the star system. So say you've got a star system with 4 planets, and say the star is called GD5. Then the planets closest to GD5 would be GD5b. Then the planet after that would be GD5c, GD5d, GD5e, right? But using telescopes that are in space is a lot more, there's a lot more to finding a planet than just looking for it. So, introducing the transit method. Really, it's just when a planet blocks some of its star's light. So imagine, you know, when we have like a lunar eclipse and the moon blocks the sun's light, and from Earth we don't see the sun anymore. That's what happens with the planets eclipsing their star. So when we see a dimming in the light of a star that we're measuring, we're like, okay, that's interesting. Is there like an asteroid, or is it actually a planet? And then we wait and we see if that dimming happens again. The transit method is faulty. It picks up large planets that are closer to the star, that are easier to detect. And even with planets that are closer to its star, it only detects about 10% of hot Jupiters, and the rest go undetected. So the transit method cannot be used on its own. And if you want me to do a video describing more methods of finding exoplanets, please let me know. And I think I will, because it's a lot of information for a 15-minute video. Now, my list of 10 awesome exoplanets that you need to know about. So the first exoplanet that I've got on my list is WASP-12b. This is a gas giant and it orbits super close to its star. It's actually part of a category of exoplanets called hot Jupiters, because in many ways it's exactly like Jupiter, but it's like thousands of degrees hot. It orbits super close to its star, WASP-12. So close, in fact, that its year only lasts one Earth day, and the planet itself is shaped like an egg. But it's 1,200 light years away, so you ain't seeing that anytime soon. So next on our list is HD 189773b. This gas planet rains glass, and that's because there's silicates in its atmosphere. So like it has silicon in its hot atmosphere, and the silicon is blown around by high-speed winds and then is superheated into glass, which then falls as glass shards. Isn't that like really cool? It's actually like super crazy. And you wouldn't think that looking at this peaceful blue dot. But what else looks like a peaceful blue dot from far away? Earth. And Earth is something else, man. Now it's 63 light years away, which in astrophysics terms is so close. Next on our list is planet TRACE-2b. Now TRACE-2b is the darkest known exoplanet, which is why it looks so dark and red in this artist's illustration. Note, most of these planet images are either artist illustrations, or so they could look nothing like this, but this is what we can assume. And it only reflects 1% of the light that it absorbs from its star. So daytime and nighttime are practically the same thing there. There is no real difference. And it's 750 light years away. So that's pretty far, but again, for astrophysicists, it's a breeze. Kepler-22b is at a temperature that would allow for liquid water to exist. So that's why it's made it onto my list. It's not that interesting otherwise, but the thing that astrophysicists want to find most of all, especially astrobiologists, is a planet that holds liquid water. I mean, you could have a planet that rains glass and fiery rocks at the same time, but we'd be more interested in a simple planet that has water. And it's around 640 light years away. Now we have next in the list, WASP-121b. So this planet rains sapphires and also rubies. Rubies are a potential. And this is because it's a gas giant, it's extremely hot, it's tidally locked with its star, meaning one side is always day and one side is always night. That means that when the vaporized metal clouds on its day side are blown over by high-speed winds to its night side, these gaseous metals cool down to liquid and they react and form these rubies and sapphires. And it's roughly 850 light years away. Proxima Centauri b. Now it orbits a star called Proxima Centauri. And the reason I wanted to talk about this one is because of how close it is. And that's why I find it really interesting that there are planets that would take light only 4 years to reach it, which is still quite far for light. But I mean, imagine if we get a high-speed ship and we're able to get there within less than 100 years. Although, at the moment, with what we have, I mean, even Voyager 2 would take 75,000 years to get to Proxima Centauri b. But even though it's close, it's not close enough for us. The next one is GJ504b. This planet is actually very new. And I don't mean newly discovered, I mean like it's actually like new, like a few thousand years old. and it's so freshly formed and so hot that it will glow a magenta. So yeah, it's 57 light years away, but it's really interesting because it challenges our theories regarding the formation of gas giants, as it orbits its sun-like star 9 times further than Jupiter. Because the way stars form, they form in what's called a protostellar disk, which is made up of a lot of different layers of gas cloud. And gas giants often form at a certain distance from their star. But this one forms really, really far away, which kind of messes with our understanding of star formation. So next on my list is called PSR J1719 1438b. PSR stands for pulsar. So this planet orbits a pulsar, and a pulsar is a type of rapidly spinning star that is the core of a previously exploded star. A really, really dense, really, really hot, really, really small star that spins really, really fast and emits radiation. So whenever it faces Earth with these beams of energy shooting out of it, we detect pulses in energy, therefore it's called a pulsar. It's just really interesting that there's planets orbiting pulsars. That's why I put it on here. It's pretty cool. It's also made up of carbon, which means it's categorized as a diamond planet. So under the right heat and pressure conditions, it could have a diamond atmosphere. It could have diamonds falling out of its clouds. Next on our list is TOI 700d, and this is a super Earth. So that terrestrial planet that's actually way larger than Earth, and it's likely rocky. But it orbits its red dwarf star in the habitable zone, which again is what makes it really interesting that there are planets that could sustain life. So I just wanted to share this one because A, it orbits a red dwarf star, and B, it has the ability to have life. And it's roughly 100 light years away. And next we have my favorite one. It is one of the oldest exoplanets we've ever found. And that means that the stars it orbits are really far into their life cycles. So far, in fact, that one of them is a pulsar and the other is a white dwarf. That's right, this is our Tatooine planet. This is a planet orbiting 2 stars. It's called PSR B162026b. And that's because it orbits both a pulsar and a white dwarf, which is actually really interesting because pulsars are formed when really large stars die, and white dwarfs are formed when fairly small stars die. Most binary star systems, you can see both stars from every planet, but one of the stars is often orbiting further out, so that there are planets in between both stars. But this star system, there's no planets in between these 2 stars. They're orbiting each other quite close, quite fast, and then this planet is orbiting them both. And so yeah, that's, I think, my favorite planet. So that's all for me today. I hope you enjoyed my video and that you found these planets really cool. But I would like to just accredit NASA. I will put some links at the end. If you want more information that I haven't shared, please ask me questions in my question boxes on my Instagram, or you can also just look up the links I've put. Stay tuned for my next video and keep engaged with my Instagram. Please like and subscribe and comment down below. That would be really appreciated. And also share it with your friends. Alrighty, until next time, I'm Cosmic Ray, signing off.